Here we go. Number 1 says, a two-dimensional cross-section is taken of a three-dimensional object. If this cross-section is a triangle, what cannot be the three-dimensional object? So we have these 4 figures at our disposal in the multiple choice. What we need to do is we need to determine which of the following figures cannot produce a three-dimensional object. So here's what I'm going to do. I'm actually just going to draw a couple shapes or figures. So here's my cylinder to the best of my ability. No, I'm sorry. It's a cone first. Whoopsies. It's a cone. Okay. Here's a cone. Okay. Here's a cylinder. Here's a pyramid. Hopefully that will look good. Pyramid and rectangular prism. Okay. So here I have my 4 shapes. And your goal is to figure out the cross section is so they're telling you what the cross section is. The cross section is a triangle. Remember what a cross section means. A cross section is if you take a knife or whatever cutting utensil and you just slice the object. What does it give you? Okay. So which cannot be the three-dimensional object? Well, if I were to take a slicer and slice down like downwards on the cone in an up and down vertical fashion, yeah, I would get a triangle like that, or just the whole thing like this. This is a triangle right here. Okay, so a cone does work. That will produce a triangular cross section. Number 2, a cylinder. All right, well let's give it a shot. I could cut it horizontally, which would just create a disc, a circle, like a quarter. I could cut it on a slant, which would produce an oval or an elliptical shape, and I could cut it up and down, which will create a rectangle. So far, the cylinder is probably the answer, but let's go through all the other answer choices just to make sure that we're not confused. This one is a pyramid, absolutely, because you could cut it downwards, and again, you could create a triangle because they have triangular faces. So you know that it's going to be a triangular cross-section. Choice 4 is the one that got everyone tripped up. Choice 4, you are unable to see it immediately. But you need to think cleverly. What if I cut the rectangular prism? What if I cut off one of its corners? What would that give us? Well, I'll show you right now. If you cut off one of its corners, you're actually going to get the resulting image. Look at this, folks. Look at this. If I were to just slice off a corner of this, if I could draw it correctly, look at that. I could take off a chunk and it create, I know you can't see it, but it does create a triangle. Okay? I wish I could draw it a little bit better just because I know that it's pretty difficult to see. Actually, what if I draw it like this? Draw like a dot on the back. There we go. You could kind of see the triangle coming off. It's better with the picture that I drew by hand. I can't draw with this for the life of me. But just trust me that if you cut it on one of its pointed edges, it actually does create a triangle. Your answer is choice 2, a cylinder. You cannot cut it anyway and get a triangle. Number 2, the image of triangle DEF is D prime, E prime, F prime. Under which transformation will the triangles not be congruent? You, ladies and gentlemen, you are looking for a dilation. A dilation, because a dilation changes distance and congruency. Okay, reflection. No, that's a rigid motion. Reflection. No, that's a rigid motion as well. A dilation with a scale factor of 1/2, 3. Uh-oh. A dilation with a scale factor of 3/2 centered at the origin. Ooh, wait a minute. They're both dilation. What do I do? Here's the thing. A dilation with a scale factor of 1. That's the key here, ladies and gents. A scale factor of 1 does not change anything. So it's the scale factor of 1. Just like in algebra, if you take a number times 1, it's just the number 5. In this case, 5. 5 times 1 is it's itself. It's 1 times anything is itself. So that's why a dilation of 1 is actually not going to change a thing. A dilation with a scale factor of 3/2, yeah, that's going to change something. 3/2 is the same thing as 1.5. You're going to get 1.5 times larger than the original figure. So that's why the answer for not congruent is actually going to be choice 4. This one does actually preserve everything. Even though that it is a dilation, it still preserves everything just because that scale factor was so special. It had a scale factor of the number 1. All right, so your answer is choice 4. Number 3, the vertices of square RSTV have the coordinates -1, 5, -3, 1, -7, 3, and -5, 7. What is the perimeter of RSTV? So here's the thing. You could actually save a lot of time on this question. What they really want you to do, and what should be jogging in your head right now, is do the distance formula 4 times, add them all up, and you get your perimeter. Because perimeter means adding up all the sides. But the problem is, well, it's not really a problem, but it's a square. Why make yourself do all extra work, do the distance 4 times on all of its sides, when in a square, all 4 sides are congruent? Right? Can't we just take the distance of one side, then multiply that number by 4, and you get your perimeter? Of course you can. So what I'm going to do is I'm actually going to calculate the length of side RS using the distance formula. The distance formula, if you don't know it by now, it's the square root of x2 minus x1 squared plus y2 minus y1 squared. I'm going to plug in these coordinates. -1 and -3. So I'm going to put the -1 first. Doesn't really matter. Minus a -3. Watch out for your signs. 5 minus 1 squared. So d is equal to the square root of, this is going to be +2 squared plus 4 squared. D is equal to the square root of 4 plus 16, which is the square root of 20. Okay? This is the length of one side. To get the perimeter, well, there's 4 sides in a square, so you just simply take 4, multiply it by radical 20. Your answer is just 4 radical 20. That's how you multiply it. Your answer is choice 3. It is not choice 1. That's the trick. And it's certainly not choice 4 and choice 2. That makes no sense whatsoever. So your answer is choice 3. Moving on. Number 4. Okay, this one was certainly an easier question. Thank goodness. In the diagram below of circle O, chord CD is parallel to diameter AOB, and the measure of arc CD, is 130 degrees. Okay, I'm going to label that right now. 130 degrees. Now, what you need to know is this. They specifically said that CD is parallel to AB. Why would they tell you that? Because you need to know a theorem. Very important theorem, actually. Here's our theorem. Parallel chords. Because a diameter is, in fact, a chord. It's actually the longest chord of the circle. Parallel chords intercept congruent arcs. What in the world does that mean? Well, in easy terms, if the chords are parallel to each other, the chords are on the inside of those two lines are congruent to each other. So arc AC is congruent to arc DB. That's important. Now, we're trying to find the measure of arc AC. So what I'm going to do is I'm going to call this X. But since these are congruent if this is X, then I'm going to label DB as X. Well, why would I do that? I need to solve for one of those X's. But the problem is here is we are given this. What is this, folks? What is that? That is a semicircle. And a semicircle is 180 degrees. Okay? The reason why it's a semicircle is the minute you see the diameter hit the circle, this is 180 and this is 180 down below. But we're not going to count that. We only care about the semicircle. Why do I care? Because what I could do is I could just make an equation. I could add those x's. I could add the 130. And I could set that all equal to 180 degrees because of the semicircle. Now just combine like terms and solve. I'm going to combine these two x's. We get 2x. I'm going to subtract the 130 on both sides. So we get 2x is equal to 50. Divide by 2 on both sides. And you get x equals 25. So each individual is 25. Now, if you want to check yourself, take 25 plus 130 plus 25 and make sure that it equals the semicircle of 180 degrees, and it does. Your answer is choice 1. Pretty simple question. Make sure you know it. Okay, number 5. In the diagram below, AD intersects BE at C, and AB is parallel to DE. Now, why would they tell you that AB is parallel to DE? Well, this tells you that triangle ABC is similar to triangle DEC by angle-angle similarity. Because parallel lines that are cut by a transversal forms alternate interior angles that are congruent, and these are vertical angles. We could prove it by angle-angle similarity. But what does that even have to do with anything? I just pull that out of nowhere? No, not really. If you look down here, it's telling you the lengths of these measurements. If CD, which is over here, is 6.6, and DE is 3.4, and CE is 4.2, and BC is 5.25, then what is the length of AC? The reason why I told you that these two triangles are similar is for the sole fact that you need to set up a proportion to get this question right. So we need to solve for x. You need to pull the important information. X is in proportion to the 6.6, okay? AC is in proportion to CD. Just because if you rotate this triangle onto that one, those two would be corresponding to each other, okay? And 5.25 is in proportion to the 4.2. So now I'm just going to set up a very basic proportion. I'm going to say X is to 6.6 as 5.25 is to 4.2. Okay? Make sure that you are consistent. So I went from this triangle to this triangle. I have to do the same thing. This triangle to this triangle. Now we just cross multiply. So we get 4.2x is equal to 6.6 times 5.25. Just take my word for it. It is 34.65. Divide by 4.2 on both sides of the equation or equal sign. And x is equal to 8.25 when you divide that. And your answer is choice 4. Pretty simple stuff. Not too shabby. All right, moving on. 6. As shown in the diagram or the graph below, the quadrilateral is a rectangle. Which transformation would not map the rectangle onto itself? What does that mean? Not map the rectangle onto itself. You're looking for, or you're asking yourself the question, which line or point, I should say, let me erase this, because I do see some rotations in the answers. Which line or point is not symmetric? In other words, if you rotate or reflect this rectangle and it doesn't have symmetry, that's your answer. So let's take a look at choice 1 and let's see if this will help you. A reflection over the x-axis. Well, if you reflect over the x-axis, right? If you reflect over the x-axis, this is what we get. That's the x-axis. Is the rectangle symmetric on both sides? It's symmetry. It's basic symmetry that you learned in like elementary school. So is this symmetric to this? Of course it is. And if you're not so sure, count up the little boxes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. There's 4, 8, 12, 20 boxes, and there's 20 boxes down here. Of course it's symmetric. So choice 1 would be incorrect because that does work. It's asking you for the one that's not mapping it onto itself. A reflection over the line x equals 4. Oh boy, every geometry student's nightmare is to graph vertical lines. That's a vertical line. Okay? So the line x equals 4 passes through all values where x is equal to 4. Okay? We'll just go 4 to the right. 1, 2, 3, 4. You're going up and down like this. Is that a line of symmetry for this rectangle? Of course it is. Absolutely. It's symmetric on both sides. This is symmetric to this. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20 boxes. 2, 4, 6, 8, 10, 12, 14, 16, 20 boxes. So that does work. Let's keep going. So for the third one, It says a rotation of 180 degrees about the origin. So they're saying if you rotate it 180 degrees about the origin, it's saying that this will rotate one entire semicircle and end up right over here in this vicinity. Now, I know this is going to bother a lot of you. Oh, I just drew that too small. I know that this is going to bother many of you. I asked the question, is that symmetric? And if you said yes, you're thinking of congruency. You're not thinking of symmetric. Symmetric means that you are literally cutting something in half or you're spinning it around to overlap itself. This is clearly in a distant galaxy away from this rectangle. So therefore, choice 3 is the correct answer. Now, of course, I'm going to show you why choice 4 is incorrect. Let's take a look at choice 4. A rotation of 180 degrees about the point 40. Okay. 40. 1, 2, 3. So we're rotating about this purple point. We rotate it 180 degrees. We spin it all the way around by one semicircle. We spin it once. 180 degrees. It goes like this, and it spins it around onto itself. It is symmetric. The figure does not move. Technically, it does move, but it overlaps itself. That's the key there. It overlaps itself from the beginning. So that's why choice 4 is incorrect. Choice 3 is the correct answer in this case. Moving on to number 7. In the diagram below, triangle ACD has points B and E on sides AC and AD respectively, such that BE is parallel to CD. AB is 1, BC is 3.5, and AD is 18. Really quick again, they keep bringing this up. And if you haven't caught on with the pattern yet, make sure you do. They keep telling you that something is parallel to something. That's important because, again, it tells you that you're creating similar triangles by angle. Okay? Parallel means, well, this is congruent to this because those are corresponding, and angle A, little a up there, is reflexive in the little triangle and the big triangle. This is important stuff, people. So make sure that you know what that means. What is the length of AE to the nearest tenth? So we're solving for this. Okay. There's a couple ways that you could do this proportion. I am going to go the easy way, and I'm going to say, let's set this one in proportion to this x, and let's set this whole side in proportion to this whole side. Well, the problem is we need to add this. 3.5 plus 1 is 4.5. We're missing that one piece. If you're thinking 1 over x equals 3.5 or 18, you're missing the 1. Very important to include that. So 1 over x equals 4.5 over 18. There are so many different ways that you can set up that proportion. It doesn't matter what you do as long as you get the right answer, you're fine. Cross multiply. 4.5 x equals 18. Divide by 4.5 on both sides. Take my word for it. X is equal to the number 4. When you divide that, your answer is choice 4. Simple stuff, basic similar triangle proportions. Make sure you know how to do them. Number 8, in the diagram below of parallelogram rock, angle C is 70 degrees and the measure of angle ROS is 65 degrees. What is the measure of angle KSO? We're looking for this. All right, let's talk about a parallelogram. Opposite sides are congruent. Opposite angles are congruent. Consecutive angles are supplementary. All this should be jogging in your head. But since we're working with angle measures, we're just going to focus on the angle measures. We're going to say that opposite angles are congruent and consecutive, meaning the ones that are next to each other, consecutive angles add up to give you 180 degrees, meaning supplementary to each other. So that means if this is 70 degrees, the angle next to it, or the adjacent, or the consecutive angle, is going to be 180 degrees minus the 70. This angle over here is actually going to be 110 degrees. We're just filling in a whole bunch of information that we need to know. Now, we just said that opposite angles are congruent. If this is 70, all the way over here, this is also 70 degrees. Well, folks, what is this right here? That is a triangle. How many degrees are there in a triangle? 180 degrees. So we just take 180 degrees minus the 70 degrees minus the 65. What are we trying to find? We're trying to find that little angle in the corner right here. because if we find that one, we get the blue one next to it. So this is actually going to be equaling 45 degrees. So this angle right over here is 45 degrees. We can now find the supplement, which is next to it. This is the goal, the purple angle right there. We're trying to find that angle. So what we need to do is just take 180 degrees minus the 45 degrees, and you get 135 degrees. That is the measure of angle KSO. Pretty simple question. I didn't think it was that bad. Number 9. In the diagram below, the measure of angle GRS is congruent to the measure of angle ART, and GR is 36, SR is 45, AR is 15, and RT is 18. Which triangle similarity statement is correct? Okay. So the problem is you can knock out angle immediately. We're only given these in the instructions. These are the vertical. No, they're not vertical angles. I'm sorry. They're not vertical. So we're just given that these two angles are congruent to each other. That means we knock out angle. Okay? Now, we're not even given... Now, take a look at choice 3. We're not even given a third side. So that immediately knocks out. We don't know what AT and GS are. Not a clue. So from here, it's either side angle side similarity or they're not similar at all. Let's go ahead and set up these proportions. Let's do 36 over 45. Is that equal to 15 over 18? Now, if you have the TI Nspire, this will go very quickly for you. You can actually type in the fractions. If you type in control division, 36 over 45, and there's an equal sign right underneath the blue control button, if you press equals, control division, 15 over 18, it will actually tell you if it's true or false, if these fractions are the same, and the answer is false. That means if this totally wipes out, does not work, backfires, fails, choices 1, 2, and 3 are out. These triangles are not similar, folks. They're not, because the sides are not in proportion. Even though that there's an angle there, the sides are not in proportion to each other. These two triangles are not similar. Your answer is choice 4. Number 10, the line represented by the equation 4y equals 3x plus 7 is transformed by a dilation centered at the origin. Which linear equation could represent its image? So here's the quick thing that you need to know about this. It's saying you're dilating a line. Basically, and many of you might be thinking, how do you dilate a line if a line is continuous and goes on forever? You're just moving the y-intercept up and down. That's what dilating a line means. So what we need to do is we need to see first, or figure out, does the origin lie on this line? Because if it does, we have a very different story. Let's check 0, 0. Okay? Let's make sure that this origin is not on this line. Let's do it. So we get 4y equals 3x plus 7. I'm going to substitute 0 in for x and 0 in for y. 4 times 0 equals 3 times 0 plus 7. 0 equals 0 plus... Does 0 equal 7? No. That means that the origin does not lie on this line. That's a good thing. Because if the origin... Let's just say this. If the origin was on this line, the dilated line or the dilated image would actually be the exact same thing. And if you did the June of 2017 Regents exam, one of the part 2 questions asked for that specific concept. And if you don't know what I'm talking about, I suggest that you go back and look at that video. It's the June 2017 exam, parts 2 through 4. Okay, so we know that it doesn't lie on the line. Perfect. So now what I'm going to do is I'm going to put this into y equals mx plus b form. So, we get 4y equals 3x plus 7. Divide by the 4 on both sides. We get y equals 3/4 x plus 7/4. Now, what is the goal here? Our goal is to find one of the answers of the line that has the same slope as 3/4 and has a different y-intercept of this line. So we're looking for this. This is the golden egg right here. 3/4. We're looking for which of the following answers has a slope of 3/4. Let's go ahead and try choice 1. I'm going to subtract the 3x on both sides. So we get negative 4y equals negative 3x plus 9. Divide by the negative 4 on all sides. Sorry for the messy stuff. It's all congested. So we get y equals now negative 3 divided by negative 4. That gives you a positive answer. That's 3/4 x plus a negative 9/4. Wait a minute. Wait a minute. 3/4? 3/4? Different y-intercepts? Bingo. Your answer is choice 1. Very simple stuff. All right. Yeah, nothing more to add. Same slopes, different y-intercepts. There you go. There's a dilated line, or an example of a dilated line. Number 11. Given triangle ABC with the measure of angle B equaling 62 degrees and side AC extended 2D as shown below, which value of x would make AB congruent to CB? In other words, which value of x would make this an isosceles triangle? Okay, so your goal, in fact, is to forget about this x completely. Isn't that funny? Completely take the x and put it out of your brain. Don't look at it. Let me help you with this one. I'm going to call this y, this angle over here y. I'm going to call this y as well. Why am I putting y's all over the place? Y. So this needs to be an isosceles triangle. According to the isosceles triangle theorem, if you have two congruent sides, the angles opposite those congruent sides are congruent to each other. Okay, so we want to add all of these angles. So y plus 62, and we want to set it equal to 180 degrees, solve for y, then solve for x. So in order to solve for y, we get 2y plus 62 equals 180. I'm going to subtract the 62 on both sides. We get 2y is equal to 118. Then you just divide by 2 on both sides, and you get y is equal to 59, okay? So each individual angle on the bottom is 59. So this is 59, and this is 59. It's asking you to solve for x. This is a linear pair. That means it's 180 degrees in total. So you're just going to take 180 degrees minus the 59 degrees, and that will give you angle x, which in this case, it's 121. Okay, so x is equal to 121. Your answer is choice 4 for that question. All right, last question coming right up. Here we go. Number 12. In the diagram below, PA is tangent to circle T at A, and secant PBC is drawn where point B is on circle T. If PB is 3, and BC is 15, what is the length of PA? So you need to know your circle segment relationships. This is a tangent. A tangent just means it is drawn from an external point touching the circle at one individual point. In this case, the external point is P, and it's touching at A. A secant, I call a secant an extended chord. It passes through the entire circle, touching at two endpoints, and then passing over to an external point. In this case, it's P as well. So this is a secant. What relationship do you know between a tangent and a secant for segment relationships of a circle? I hope what's coming to your head is WE equals T squared, wet squared. What this stands for is whole times external is equal to the tangent squared. Now, it's not the same tangent as in SOHCAHTOA tangent like sine, cosine, tangent. It's a different tangent as in the segment of the circle. And if you have no idea what I just wrote down, then you need to download my Facts You Must Know codes for the geometry regions for this exam. Go down in the description, go on my website, go to geometry, go to Facts You Must Know code, download it. All this information can be found there. Make sure that you know how to do this because it does come up occasionally. So, what does all this hoopla mean? So let's go ahead and talk about this. The whole times the external. WE is specifically talking about the secant. So the secant, the whole thing, is 15 plus 3, which is 18. Okay? And the external piece, the outside piece, is the number 3. And the tangent is just x. So let's go ahead and plug it into our formula. The whole thing is 18 times the external, which is 3, equals x squared. 18 times 3 is 54, which is then equal to x squared. Okay? So now what we need to do is we need to take the square root of this. Okay, I hope that you remember how to simplify radicals from Algebra 1. So, you need to think of the highest perfect square that goes into 54. The highest perfect square that goes into 54 is 9. And then 6 carries on for the right, because 9 times 6 gives you 54, but we're breaking it down in terms of radicals. The square root of 9 is the highest perfect square of radical 54. So the square root of 9 is 3. The radical 6 comes along for the ride. That equals your value of x. Your answer is choice 2.